In the previous video, we looked into basics of IPFS and learned a lot of concepts theoretically. This one we will be running a IPFS node and playing with some CLI commands. So let's get started. In order to install IPFS, you can just simply type install IPFS. IPFS is also called Kubo. And let's go to this installation URL. So here you will go to daemon or CLI and just drop down a little bit, and there are the steps. So based on which environment you are using, you can follow these steps and install the IPFS node. Once you have installed this node, you need to initialize it, and for that you just go into the bottom and click here, and you can run IPFS in it. And profile server, so there are different profile in which you can run a IPFS node. You can simply initialize using init without server. If you are running on a server and providing it to various users or using it on a server way, you can use server. There are more profiles as well, like one is power saver profile. So if you are you have limited resources, then you can use that power saver profile. So in the docs you can find details of all the different profiles in which you can run the IPFS node and see more about which suits best your use case. Now after you have initialized the node, let's see firstly if it is installed correctly or not. So I will write IPFS version, so it will return the version in which you are in. So even if you are in later version, since after IPFS is getting updated quite frequently, so you might not be on this particular version, but that's nothing to worry about, because the basics remains the same, and there won't be significant changes in some common commands which we'll be using. Now in order to start IPFS node and connect to the IPFS network, we will write IPFS daemon, and that's it. Now we are part of the IPFS network. So let's look at the log. It is the IPFS version which I'm using. This is my system information, ARM64, and I'm using 0.1.23 Golang version. My peer ID. Peer ID is also a public private key pair generated using that. Then this information is used for connecting with other peers. So I'm using both TCP and UDP protocol in my config, and this is my v4 IP address and v6 IP address. Next, if you want to connect with IPFS node using any programming language, you can directly use it using the IPFS API, which is hosted on port 5001. And in order to view the file, we use IPFS gateway, which is hosted on port 8080. And they also provide a web UI version which you can run using this particular URL. Now I will be opening another tab and type IPFS ID. So it shows me a bunch of information. First is my ID, second is public key, which is not much used. This particular ID is mostly used when we are connecting with other peers in the network. These all addresses are called multi-address. So multi-address has a this entire format is called a multi-address. So you have /IPv4, then the IP address, then TCP, then the port P2P, and then your peer ID and everything. Combined, this entire thing is called a multi-address. So you can also use this multi-address as well when connecting with other peers. Then this is the IPFS version which I'm using. These are the different protocol which are running when I'm running this IPFS node. Bitswap is used for exchanging of data between the peers. So if you are exchanging a file, you will be using this protocol. ID is again a protocol here. Ping, like you have ping in your bash command, you type ping google.com to see if google.com is alive or not. And similarly, you can ping an IPFS node to see if it is you are able to connect with it or not. So this is it. Now I will clear it and I will go to another location, .ipfs. So in the home directory, when after you run IPFS init command. After the installation you ran this command. After running this command, this particular folder is created in the home directory. You can use a IPFS path command, a path while writing the init command if you want to make sure that this folder is created somewhere else with a different name. That's also possible. Now let's see what are the files inside it. These two files, API and gateway, are nothing but just storing the URL of API and gateway. So same multi-address. Now important one are these blocks and data store. So let's see what inside blocks. So many folders. Okay, let's go inside a specific folder. You can see different files. Within these files your data is stored. So what happens is, once you add a file into your IPFS node, the file gets chunked by default into 256 KB chunks. So each chunk represent these files, and those chunks are stitched together using a Merkle tree, and Merkle root is the CID which IPFS returns. If you want to know how these folders are getting created, you can read this underscore readme file. It will show you the formatting. Now let me go to data store. Block store was storing the entire file, and data store stores the metadata information, like whether the file is pinned or unpinned. These kind of information are stored in data store, and IPFS uses by default level DB to store the entire metadata logs. Now let's see again. Key store is used for IPNS. So we have not discussed IPNS for now. You can ignore it for now. So key store is used for storing those keys, the IPNS keys, and then you have lock and the version. Now let me go back to my desktop testing folder, and let's see some CLI commands. So if I go to IPFS API, and here I will go to CLI. If you want to use RPC APIs, you can click on HTTP one, and the most common one is the add. Let's see, IPFS add. We use add command to add the file on our node so that we can provide it to other peers in the network. So I have a file called dragonball.fp. This returns me this particular string which we called as the CID, and this CID can be used by any peer in the network to fetch this file from my node or any other node which is hosting this file. But this CID is CID v0. v0 CID starts with QM. If I want it to be a v1 CID, which is now more commonly used, we can use this particular flag CID version. Okay, I'm on the add command, and it must be somewhere here. CID version, this one. Now it returned me a v1 CID. Let's try to view this particular file. So if you remember, in our daemon it says 8080 is used for hosting gateway. So I will go to localhost .8080/IPFS/ this particular CID, and I can view this particular file. So we added the file into our node, we viewed the file using the gateway, and this particular file can be used by other peers to create a copy. We can try some more commands now. So bitswap, like bitswap reprovide. So the peers your peer is connected to it, your peer will provide all the files that he has to them, and it happens using reprovide, and it works like every 22 hours I think by default, but you can, if you want to reprovide it right now, you can just trigger it using this. and these are the block commands. So you remember the blocks folder. In that folder you have different files, those are blocks, and you can use these command to interact with those individual blocks. Then you have the bootstrap. So bootstrap, if you remember, bootstrap peers are the peers you are connected to when your node is getting initialized. So IPFS bootstrap list. So these are the peers I am connected to by default. You can add, remove the bootstrap peer. You can cat a file. I can just simply cat it. Yeah, it will be something gibberish, but you can do it, or you can just store it into another file, dd.jpeg maybe. So now this file is stored in this file as well. Next is some more command related to CID. Let's see, config file we will be looking into next video, but you can edit it using CLI as well. daemon we already ran. DAG. So files are stored using a Merkle tree, and we call it a DAG. So let's try IPFS DAG get. Let's try to view a particular DAG. It's this big. Maybe you can just pretty it using online tool and see how everything is connected. It's a kind of a linked list tree data structure. Next is distributed hash table commands and files. This is called MFS. You can read more about it into the docs. In short, what it does is, if you want something more like a folder kind of a structure, you want to create a folder, and within that folder you want to store a file, then you can use these commands, the MFS commands. We already ran id init. Let's go to the pin command, this one. We can get a file from other peers into our system locally using this pin command. We will try this out. So let's go to OpenSea first. .io. Okay, let's try this one. So token URI, let's try the token 1. Yeah, this is on IPFS. So we will take this particular CID and /1. IPFS pin add. Okay, this was fast, but normally it can take time. It depends. Firstly, your node will find that particular peer, and then it will start downloading the file into your system locally. Now, so some peer in the network just gave me this file. Now it is stored with me locally and pinned as well. Now if I copy this CID, and instead of this, again localhost 8080/IPFS/CID, I can view this. Okay, so this is the metadata URL, and within this it contains another IPFS URL. Let's take this then and pin this also. Okay, it's taking a little time. Let's wait. It's pinned. Now we can go to this. Just replace this with. The file is here. Now it's in my local system. We just downloaded it from the IPFS network. So this is how pinning works. Alright, so I think we have covered a lot within this video. You can explore more commands. There are a lot of commands, and these keep getting updated with every new version. So You can try a bunch of them based on your use cases. Thanks for watching. Have a good day.